हॅलो स्टुडंट, वेलकम टू अवर चॅनल महाराष्ट्र मीडिया. मी गायत्री सदाफळ तुमचं महाराष्ट्र मीडिया या चॅनलवर मनापासून स्वागत करते. तुम्ही अजूनही आमच्या चॅनलला सबस्क्राईब केलं नसेल तर चॅनलला सबस्क्राईब करा आणि साईडला दिलेल्या बेल आयकॉनला प्रेस करा. ओके स्टुडंट, सो लेट्स स्टार्ट विथ द क्लास 10 सायन्स सोल्युशन पार्ट 1 चॅप्टर नंबर 3 केमिकल रिएक्शन्स अँड इक्वेशन्स. ओके, सी द क्वेश्चन नंबर फर्स्ट. Choose the correct option from the bracket and explain the statement giving reasons. Oxidation, displacement, electrolysis, reduction, zinc, copper, double displacement and decomposition. A question. To prevent a rusting, a layer of dash metal is applied on the iron sheets. Answer. To prevent a rusting, a layer of the zinc metal is applied on the iron sheets. The rusting of iron is an oxidation process due to the corrosion of an iron. A deposit of the reddish substance Fe2O3.H2O is formed on it. Thus, substance is called as a rust. To prevent the corrosion, a layer of zinc metal, which the process is known as a galvanization, is applied on the iron sheets. Question number B. The conversion or the ferrous sulfate of the ferric sulfate is a dash reaction. Answer. The conversion of ferrous sulfate to ferric sulfate is an oxidation reaction. When ferric ion is formed from ferrous ion, the positive charge is increased by 1 unit. While this happens, the rarest ion loss 1 electron. A process in which a metal or its ion loses one or more electrons is called as a oxidation. 2FeSO4 gives rise to FeSO4 thrice, which gives Fe2 plus SO4 2 minus gives rise to twice Fe3 plus SO4 2 minus. The net reaction is Fe2 plus, that is a ferrous form, gives rise to ferric form, that is a Fe3 plus electron. Okay. Question number C. When electric current is passed through acidulated water, dash of water takes place. When electric current is passed through acidulated water, decomposition of water takes place. In this reaction, hydrogen and oxygen gas are formed. This decomposition takes place with the help of electric current. It is called as electrolytic decomposition. Twice H2O gives rise to twice H2 plus O2 in presence of electric current. D. Addition of an aqueous solution of ZnSO4 to an aqueous solution of the BaCl2 is an example of dash reaction. Answer. Addition of an aqueous solution of ZnSO4 to an aqueous solution or BaCl2 is an example of double displacement reaction. Here is a not or, it is a of. Okay. So reaction is a BaCl2 in aqueous medium, that is a barium chloride, plus ZnSO4 in aqueous solution, that is a zinc sulfate, gives rise to BaSO4 precipitation. This symbol indicates the precipitation. Okay, that is a barium sulfate, plus ZnCl2 in aqueous, it is a zinc chloride. Barium chloride reacts with the zinc sulfate to form a white precipitate of the barium sulfate. White precipitate is formed by exchange of ions Ba++ and SO4- between the reactions. Question number 2. What is the reaction called as a when oxidation and reduction takes place simultaneously? Explain with one example. Answer. The reaction which involves the simultaneous oxidation and reduction is called as a oxidation reaction or redox reaction. In redox reaction, one reactant gets oxidized while other get reduced during the reaction. Redox reaction is equal to oxidation plus reduction. In redox reaction, the reductant is oxidized by the oxidant and the oxidant is reduced by the reductant. Example, CO, copper oxide in solid form plus H2 in gaseous form gives rise to copper in solid form and H2O, that is a water molecule. In this reaction, oxygen is removed from the copper oxide, therefore it is a reduction of copper oxide, while hydrogen accepts the oxygen to form a water, that means oxidation of hydrogen takes place. Thus oxidation and reduction reaction occurs simultaneously. Other examples of the redox reactions are twice H2S, that is a hydrogen sulfate plus SO2 sulfide gives rise to thrice S sulfur plus twice H2O. After that MnO2, that is a manganese dioxide plus 4HCl gives rise to MnCl2 manganese chloride plus twice H2O plus Cl2 is evolve. Okay, this symbol indicate the evolution of any gas. Okay, question number B is how can the rate of the reaction, chemical reaction, namely decomposition of hydrogen peroxide is increase? Answer, at room temperature the decomposition of hydrogen peroxide into water and oxygen takes place slowly. However, the same reaction occurs at the faster rate on adding manganese dioxide powder in it. C. Explain the term reactant product giving example. Answer, the substance which undergot the bond breaking while taking part in the chemical reaction is called as a reactant. The substance formed as a result of the chemical reaction by formation of new bonds is called as a product. Example, in chemical reaction the formation of the carbon dioxide gas takes place by combustion of coal in air. In this reaction, coal, that is a carbon, and oxygen from air are reacts while carbon dioxide is product formed. Question number D. Explain the type of reaction with references to the oxygen and hydrogen. Illustrate with example. Answer, with reference to the oxygen and hydrogen, there are two types of reaction. First is oxidation reaction and second is a reduction reaction. First, oxidation reaction. Example, when carbon burns in air, it forms a carbon dioxide. In this reaction, carbon accepts oxygen. Therefore, this reaction called as a oxidation reaction. Carbon plus oxygen, that is O2, gives rise to CO2. Second point, when sodium reacts with the ethyl alcohol, sodium ethoxide and hydrogen gas is formed. In this reaction, hydrogen is removed from the ethyl alcohol. Therefore, this is an oxidation reaction. That is a twice C2H5OH ethyl alcohol plus twice sodium gives rise to twice sodium ethoxide, that is a C2H5ONA plus H2 hydrogen is evolved. Third point, acidified potassium dichromate K2Cr2O7 to H2SO4 oxidizes ethyl alcohol to acetic acid CH3CH2OH. It is a structure of the ethyl alcohol gives rise to CH3COOH, that is a acetic acid plus water molecule in presence of what? That is a reducing oxidizing agent called as a K2Cr2O7 in presence of H2SO4. Okay. Question number second, reduction reaction. Example, when hydrogen gas is passed over the black copper oxide, a reddish color layer of copper is formed. In this reaction, an oxygen atom removed from the copper oxide to form a copper, hence this is a reduction. Copper oxide CuO in solid form plus H2 in gaseous form gives rise to copper in solid form plus water molecule in liquid form. Second point, when the hydrogen gas is passed over the red hot coke, methane is obtained. Here, hydrogen is added to the coke, hence this is a reduction reaction. Carbon plus twice H2, that is a hydrogen gas, gives rise to methane in gaseous form. Okay. See the question number E. Read that question first.
Development of high quality medical facilities in urban areas bring many patients and their family members from parts of the area.
Read. Explain the similarity and differences in the two events, namely adding NaOH to water and adding calcium oxide to water. Answer. Similarly, both NaOH and CaO, when dissolved separately in water, solid NaOH dissolve, releasing heat, resulting in a rise in temperature. This reaction is an exothermic reaction. When solid calcium oxide dissolved in water, calcium hydroxide is formed. Large amount of heat is evolved. This reaction is also exothermic reaction. Both reactions are combination reactions and single product is obtained. NaOH plus H2O gives rise to NaOH plus heat. Calcium oxide plus H2O gives rise to calcium hydroxide plus heat. Difference. First point, aqueous solution of NaOH is considered as a strong alkali. Second point, aqueous solution of the calcium hydroxide is considered as a weak alkali. Question number 3, explain the following terms with example. Point A, endothermic reaction. Answer, endothermic reaction. The reaction in which the heat is absorbed is called as a endothermic reaction. When KNO3, okay, potassium nitrate dissolved in water There is absorption of heat during the reaction and the temperature of solution falls. KNO2 in solid form plus water in liquid form plus heat gives rise to KNO3. Point B, combination reaction. Answer, when two or more reactants combine in a reaction to form a single product is called as a combination reaction. Example, first point, the ammonia gas react with the hydrogen chloride gas to form a salt in the gaseous state. Immediately it condenses at a room temperature and gets transformed into the solid state. Ammonia, that is NH3, hydrogen chloride, that is HCl, gives rise to ammonium chloride as a single product. Second point, magnesium burns in air to form a white powder of magnesium oxide as a single product. 2 mg magnesium plus O2 gives rise to, in presence of heat, gives rise to 2 mg of magnesium oxide, a single product. Third point, iron react with the sulfur to form a iron sulfide. Iron, it's a Fe plus sulfur is a S, and in presence of it gives rise to iron sulfide. Question number C, balance equation. Answer, in a chemical reaction, the number of atoms of the elements in the reactant is the same as the number of atoms or atoms of those elements in the product. Such an equation is called as a balance equation. Example, AgNO3 plus NaCl gives rise to AgCl plus NaNO3. That is a reaction of precipitation of the silver chloride. Okay. In the above reaction, the number of atoms of elements in the reactant is same as that of the number of atoms of element in product. Question D, displacement reaction. Answer, the reaction in which the place of ion of less reactive element in a compound is taken by the another more reactive element by the formation of its own ions is called as a displacement reaction. When zinc granules are added to the blue color copper sulfate solution, the zinc ions are formed from the zinc atom takes place of copper 2 plus ions in CuSO4 copper sulfate, and copper atoms formed from the copper 2 plus ions come out, that is, the more reactive zinc displaces the less reactive copper from the copper sulfate. Zinc, that is a solid, plus copper sulfate, that is a CuSO4 in aqueous, gives rise to ZnSO4, that is a zinc sulfate, colorless, plus copper and plus heat. Question number 4, give scientific reason. Point A, when the gas is formed on heating, limestone is passed through the freshly prepared lime water, the lime water turns milky. Answer, when limestone is heated, calcium oxide and calcium dioxide are formed. This carbon dioxide gas passed through the freshly prepared lime water, insoluble calcium carbonate and water is formed. In this reaction, lime water turns milky. CaOH2, that is a calcium hydroxide plus carbon dioxide gives rise to CaCO3, that is calcium carbonate plus water molecule. B point, it takes time for the piece of the Shahabad tile to disappear in HCl, but it is powder disappear rapidly. Answer, the rate of reaction depends upon the size of the particles of the reactant taking part in the reaction. The smaller the size of the reactant particle, more is their total surface area and faster is the rate of reaction. In the reaction of dilute HCl with the pieces of Shahabadi tile, CO2e416 is formed. Amid the tile disappears slowly. On the other hand, CO2e416 is formed at a faster rate with the Shahabada tile powder and it disappears rapidly. Question number C, while preparing a dilute sulfuric acid from the concentrated sulfuric acid in laboratory, the concentrated sulfuric acid is added slowly to the water with a constant stirring. Answer, the preparation of the dilute sulfuric acid falls in the category of the extreme exothermic reactions. In that too, during the preparation of the dilute sulfuric acid, a large amount of water is taken in a glass container which is surrounded by the ice. Cool it for 20 minutes. Now small quantity of concentrated H2SO4 is added slowly with the stirring. Therefore, only small amount of heat is liberated at a time. This way dilute sulfuric acid is prepared. On other hand, in this process of dilution or concentrated sulfuric acid with water, very large amount of heat is liberated. As a result, water gets evaporated instantly. if it is poured into the concentrated H2SO4, which may cause an accident. D. It is recommended to use airtight container for storing oil for long time. Okay. Question is, it is recommended to use airtight container for storing oil for long time. Answer is, if edible oil is allowed to stand for long time, it undergoes air oxidation. It becomes rancid and its smell and taste changes. Second point, rancidity in the rude stuff cooked in the oil or ghee is prevented by the using antioxidants. The process of oxidation reduction of foodstuff can also be slowed down by storing it in the airtight container. Question number 5. Observe the following picture and write down the chemical reactions and explain. Okay.
Fourth is water pollution. You can see in the picture. Answer, sewage should not be allowed to mix with water sources without taking precautions.
See the diagram. What it indicates? You know what it indicates? This diagram indicates the corrosion process. Okay. See the answer of this question. That is, answer is, the rusting of iron is an oxidation process. The rust on iron does not form by the simple reaction between oxygen and iron surface. The rust is formed by the electrochemical reaction. Fe oxidizes to Fe2O3.H2O on one part of the iron surface, while oxygen get reduced to water on another part or surface. Different regions on the surface of iron become anode and cathode. In that first, Fe is oxidized to Fe2 plus in the anode region. Fe in solid form gives rise to Fe2 plus twice electron. See the reaction first. Second point is given here. Oxygen O2 is reduced to form water in the cathode region. The reaction is given here. O2 in gaseous form plus 4H plus aqueous plus 4 electron gives rise to twice H2O in liquid. When Fe2 plus ions migrate from the anode region, they react with the water and further get oxidized to form Fe3 plus ions. A reddish color hydrated oxide is a form from Fe3 plus ions. It is called the rust. It collects on the surface. Twice Fe3 plus 4H2O gives rise to Fe twice O thrice dot H2O plus 6H plus in aqueous solution. Because of various components in the atmosphere, oxidation of metals takes place, consequently resulting in their damage. This is called corrosion. Iron rust and reddish color layer is formed on it. This is a corrosion of iron. Question number 6. Identify from the following reaction reactant that undergoes oxidation and reduction. Answer, Fe, that is iron plus sulfur gives rise to ferrous sulfate. Answer, Fe plus sulfur gives rise to FeS. In this reaction, iron Fe undergoes oxidation and sulfur S undergoes the reduction. B point, twice Ag2O gives rise to 4Ag plus O2 liberated. Answer, twice AgO gives rise to 4Ag plus O2 liberated. In this reaction, reduction of Ag2O takes place. C. Twice Mg plus O2 gives rise to twice MgO. Answer, twice Mg plus O2 gives rise to twice MgO. In this reaction, oxidation of Mg takes place. D. NiO plus H2 gives rise to nickel plus H2O. Answer, nickel oxide plus H2 gives rise to nickel plus H2O. In this reaction, reduction of nickel oxide takes place and oxidation of H2 takes place. Question number 7. Balance the following equations stepwise. Okay. In that, A point, H2S2O7 plus H2O gives rise to H2SO4. Answer. Step first, rewrite the given equation as it is. H2S2O7 plus H2O gives rise to H2SO4. Step 2, write the number of atoms from each element is in the unbalanced equation and both the sides of equation. Element hydrogen, sulfur and oxygen. Number of atoms in the reactant is 4, 2 and 8. Number of atoms in product side is 2, 1 and 4. Step 3, to equalize the number of hydrogen atoms, sulfur atoms and oxygen atoms, we use 2 as the coefficient or the factor in the product. Elements are hydrogen and sulfur. Number of atoms in reactant are 4 and 2. Number of atoms in product are 2 into 2 and 1 into 2. Okay. Oxygen is 8. So, number of atoms for right side is the 4 into 2. Total atoms are 14. Here also total atoms are 14. The reaction is balanced. Now the equation becomes H2S2O7 plus H2O. It's twice H2SO4. Now count the atoms of each element on both the sides of the equation. The number of atoms on the both sides are equal. Hence the balance equation is H2S2O7 plus H2O gives rise to twice H2SO4. Now indicate the physical states of the reactant and product. H2S2O7 plus H2O gives rise to twice H2SO4. Point B, SO2 plus H2S gives rise to sulfur plus H2O. Answer. Step 1, rewrite the given equation as it is. SO2 plus H2S gives rise to sulfur plus H2O. Step 2, write the number of atoms on each element in the unbalanced equation on both the sides of both sides of equation. Elements are sulfur, oxygen and hydrogen. Number of atoms in reactant on left side is 2. For sulfur is 2, oxygen is 2 and hydrogen is 2. Number of atoms in product are 1, 1 and 2. The number of hydrogen atoms on both the sides of equation is same. Therefore, equalize the number of sulfur atoms and oxygen atoms. Step 3, to balance the number of sulfur atoms. Number of the atoms of sulfur in reactants H2O and H2S, in product sulfur. Okay, initially in H2O is the 1, in H2S is the 1. To balance 1 and 1, therefore in product there is 1 and for to balance is the 1 into 2. To equalize the number of sulfur atoms, we use 2 as the factor in the product. Now the equation becomes the SO2 plus H2S gives rise to twice S plus H2O. Step 4, to equalize the number of oxygen atoms in the unbalanced equation. Number of oxygen atoms initially 2. To balance it's a 2. In reactants that is 2 and in product that is a 1. In reactant for SO2 it is 2 and in water it is a 1 into 2. To equalize the number of sulfur atoms, we use 2 as the factor in the product, that is H2O. Now the unbalanced equation becomes SO2 plus H2S gives rise to twice S plus twice H2O. Step number 5, to equalize the number of hydrogen atoms in an unbalanced equation. Number of atoms of hydrogen initially in reactants are 2. To balance them it is a 2 into 2. In product it is a 4 and to balance them it is a 4. To equalize the number of hydrogen atoms, we use 2 as the factor in the reactant, that is H2S. Now unbalanced equation becomes SO2 plus twice H2S gives rise to twice S plus twice H2O. Now count the atoms of each element on the both sides of the equation. There are less number of sulfur atoms in the product. Now equalize the sulfur atoms. The balance equation becomes SO2 plus twice H2S gives rise to thrice S plus twice H2O. Now indicate the physical states of reactant and product. SO2 plus twice H2S gives rise to thrice S plus thrice H2O. C point, Ag is the silver plus HCl gives rise to AgCl is precipitated plus H2. Answer is step 1. Rewrite the given equation as it is. Ag plus HCl gives rise to AgCl plus H2. Step 2. Write the number of atoms or each element in the unbalanced equation on both sides of equation. Element silver, that is the number of atoms in the reactant is 1 and number of atoms in the product is 1. hydrogen, number of atoms in reactant is 1 and number of atoms in product is 2. Chlorine, the number of atoms in reactant is 1 and number of atoms in product is 1. The number of silver and chlorine atoms on both the sides of equation are same, therefore equalize the number of hydrogen atom. Step number 3, to balance the number of hydrogen atoms. Number of the hydrogen atoms of hydrogen are initially in reactant HCl is 1, in product H2 is 2. Okay, to balance them multiply 1 by 1 2 by 2. Okay, 1 into 2 that is a 2, in product that is a 2. To equalize the number of hydrogen atoms, we use the 2 as the factor in the product HCl. Now the unbalanced equation become Ag plus twice HCl gives rise to AgCl plus H2. Step number 4, to balance the number of chlorine atoms, the number of chlorine atoms are initially 2 in reactant. Okay, twice HCl, to balance them by 2. In product AgCl is 1, in AgCl is 1 and to balance therefore multiply by 2. To equalize the number of chlorine atoms, we use 2 as the factor in the product AgCl. Now the unbalanced equation becomes Ag plus twice HCl gives rise to twice AgCl plus H2. Now count the atoms of each element on the both sides of equation. There are less number of silver atoms in the reactant. Now equalize the silver atoms. The balance equation become twice Ag plus twice HCl gives rise to twice AgCl plus H2. Now indicate the physical states of reactant and products. Twice Ag plus twice HCl gives rise to twice AgCl precipitated plus H2 is evolved. D. H2SO4 plus NaOH gives rise to Na2SO4 plus H2. So answer of this chemical reaction. Step 1, rewrite the given equation as it is, that is a H2SO4 plus NaOH gives rise to Na2SO4 H2O. Now indicate the physical states of Step 2, write the number of atoms of each element in unbalanced equation of the both sides of equation. Elements are sodium, sulfur, oxygen and hydrogen. Number of atoms in the reactant are 1, 1, 5 and 3. The number of atoms in product are 2, 1, 5, 2. The number of oxygen atoms involved in a different compounds on both the sides are equal. Therefore, balance the number of atoms of the second element sodium. Step number 3, to balance the number of sodium atoms. Number of atoms of sodium begin with the 1 in NaOH. To balance them, multiply by them 2. In Na2SO4 that is a 2 and multiply it is in balance form, that is a 2. To equalize the number of sodium atoms, we use 2 as a factor of NaOH in the reactants. Now the partly balanced equation become as follows: H2SO4 plus twice NaOH gives rise to Na2SO4 plus H2O. So step number 4, now balance the number of hydrogen atoms. Number of hydrogen atoms are to begin with the in reactant in H2SO4 that is a 2, in product that is a 2. Number of atoms in hydrogen to balance them in reactant are 4 and in product it is a 2 into 2. Okay. To equalize the number of hydrogen atoms, we use 2 as the factor or H2 in the product. The equation then become H2SO4 plus twice NaOH gives rise to Na2SO4 plus H2O. Now count the atoms of each element on the both sides of the equation. The number of atoms on both the sides are equal. Hence the balance equation is H2SO4 plus twice NaOH gives rise to Na2SO4 plus twice H2. Here all the atoms in the element are balanced. Okay. Now indicate the physical state of reactant and products. Okay. H2SO4 in aqueous state, which state? Aqueous state, plus twice NaOH in which state? That is the aqueous state. This symbol denotes the aqueous state, gives rise to Na2SO4 which is also in the aqueous state. this bracket and AQ represent the aqueous state plus twice H2O in liquid. Water in liquid form, H2SO4 in aqueous form, NaOH in aqueous form and Na2SO4 in aqueous form. ओके स्टुडंट, पुन्हा भेटूया आपण आपल्या नेक्स्ट पार्टमध्ये. थँक्यू फॉर वॉचिंग. प्लीज लाईक, शेअर अँड सबस्क्राईब द चॅनल. रिमेनिंग क्वेश्चन अँड आन्सर्स आपण बघणार आहोत पार्ट 2 मध्ये.